Why do they call them black box? Is it like hard to explain these algorithms, or they are too complex that you cannot really identify why they came up with that conclusion?
No, so the thing here for the black boxes here, I think the term relates to that we can like somehow replace one model with another. So in this case, if I have a certain machine learning model that can do some analysis on certain tweets, and if we change it somehow with another model, like the same pipeline of processing the requests using the machine learning model shouldn't be changing, and we just replace one model to another. So it's just a modular, modular architecture for their pipeline. So that the whole system architecture shouldn't be changing if we change one model to another. Maybe the accuracy changing because now one model could be better than another, but the architecture and the other facilities or API features or whatever you support for the user shouldn't be changing at this point.
Because I think that there's a big field right now, especially with regard to large language models, but I'm sure that it can be applied to other AI systems. That is related to AI explainability. I
Yeah.
had a previous guest on the program who built a company just to do that. So why is it hard to explain the outcome of these AI assistants?
Right. So that's a very good question because machine learning models, like the modern ones now of these machine learning models, they are depending on more sophisticated approaches like deep learning, reinforcement learning, and other components that somehow we consider that they are doing magic inside their decision making. So it's just, you can consider this machine learning model as a set of neurons, like in a deep learning network. They are doing different possibilities in different ways. They are doing calculations and matrix multiplications in different ways that maybe it's not human intuitive, and they come up with a decision that somehow like matches our expectations. So when we try to understand this, it's somehow very hard for us to do it because you don't understand exactly. There are no steps inside this neural network, processing or inference call that can be like debugged or traced in a systematic way. You don't know exactly what's happening, and also based on the training data. So that how this model is working from inside depends on how you train it. So if you change the training data, your pattern of working inside this model can be changing as well. So you don't have like a systematic way to do this regardless the input that you have or the output that you have. So it's very hard in general. This is a very open research problem, and people started to do some progress in it, but still very far away from being mature now.
Do you feel the sense when you look at these algorithms that you're looking at a reflection of our own brains?
That's what Hinton proposed in the beginning. It's similar to how we how our brains work, uh, but there are some differences, like technical differences. But it should be the same way. It should be the same way, like how we activate the neurons and how they interact with each other while they are doing the processing. Uh, it's somehow similar to what we have in our brain, but there is there is a big difference in how they work technically, because somehow we still enforce some algorithmic steps where we are doing these activations in the neural networks that could be not similar to what we have in our minds exactly, but it's similar. Like we try to mimic or like simulate what happens.
That's fascinating. I had yesterday a professor from UCI on the program, and we entered into that kind of discussion or the differences between the human brain and AI. And
Yeah.
he said something really interesting is that the AI required large and large corpus of data, where the human brain evolved to produce intelligence with pretty little amount of data compared to what AI requires.
Exactly.
Um,
Yeah. That's actually a big difference about that, like the technicality of how it works in neural networks in our brain. So whenever we increase the training data that we have for our models, we increase the accuracy and the efficiency of the decisions that we can get from. And if your like data that you're training on is very sparse, somehow you're getting misleading answers at the end. So you have to be careful on the size of the training data, on how you train the data, how the data that you're training in is relevant to the problem that you have, because not all the data that you have could be helpful for your problem. You can somehow mislead the training process of your machine learning model if you do that.